Welcome back, and this is target problem number 7 from the 2019 chapter round. So, in this figure, how many paths go to the right and down along connected segments from point A to point B? And so, I'll present two solutions to this. The first one is a closed form solution, and the second solution is state spash. So, solution 1. So really, if we look at this, what this problem is asking for is the number of paths from A and D which don't go through either C or D. And so there's 10 to the 5 total paths from A to B, because each path corresponds to some permutation of U, and then, or not U's, actually D's, my bad. D. Some permutation of that. There's 10, choose 5 different permutations, and each of them represents one path which only goes to the right and down, and it'll go down 5 and go over 5 to the right, which will take us from A to B. And so now, we're trying to find the number of paths which don't go through either C or D. So we can also calculate that by figuring out how many paths go through C or D. So number of paths which pass through C, the number of paths that do this is the number of paths from A to C times the number of paths from C to B, which equals the number of paths from A to C is like a permutation of right to right, down, down, down. So there's 10 of those. And getting from C to B is some permutation of right, 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 down, down, which is 10. So we have 100 different paths from A to B which pass through C, which go from A to C and then from C to B. And then next we calculate the number of paths which pass through D. And that is the number from A to D times the number from D to B. And the number of paths from A to D, well, that's just permutations of right, 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 down, down, down. There's 20 of those. 6 times 5 times 4 over 3. 6 choose 3, basically. 6 choose 3 equals 20. And then the number of paths from D to B these are all represented by permutations of right, right, down, down. There's 4 choose 2 equals 6 of those. So 20 times 6, we have 120 paths from A to B which pass through D. And then finally, we calculate the number of paths which pass through both. So this way we can use some principle of inclusion exclusion. So the number of paths which pass through both is number from A to C times the number of ways to get from C to D times the number of ways to get from D to B. And we have these values from before. A to C is 10, C to D, there's only one way, and from D to B, there's 6, so there's 60. And so now we're just extracting the answer. We want the total number of paths which don't go through either C or D. So a good starting place is, so the number of paths from A to B, not including C or D, is equal to 10 choose 5, the total number of paths, minus the number of paths which pass through either. Through either C or D. But by the principle of inclusion and exclusion, the number that pass through either C or D is equal. This part over here is equal to the number of paths which pass through C, 100, plus the number of paths which go through D, 120, minus the number of paths which go through both, which we've overcounted, so 60. So we have 10 choose 5 minus 160. So 160 is the number of paths from A through B which go through C or D. And then our final answer would just be the total number of paths minus that, which is 252 minus 160, which equals 92. And then there is a second way to do this, which is a lot messier. And it would be to use states. So I'm just going to zoom in really big. And so the way to do that would be to count the number of ways to get from A to each. We label each point with the number of ways to get to that point from A. So there's one way to get here, one way, one way, one way, one way. Same with over here, there's one way to get to each of these junctures because you have to only go right or only go down. Here we can go from above or from the left, here above left for I'm gonna use a smaller font. 2, 3, 4. There's like 3 ways to get to here, 4 ways to get here, 5 ways to get here, 6 ways to get here. Same on this side, it's really just the sum of these two. You can go from either the spots of 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. And then along this channel, you have to come from here. So the number of ways for each of these is 5, except for this last one. The last one's not 5. And oh well. Okay, and the number of ways to get to this point is the sum of the thing to the left to the right, from the left and the one above. For here, it's the sum of the one to the left and the one above, the sum of the one to the left and to the one above. And here it's once again sum of the left, sum of the one to the left and sum of the one above. And this one's 11, this one is 16, 15. So we now also have that this juncture is, there's 20 ways to get here. Then this is 36 ways. This is also 36 ways. This is 56. And then finally, we have 56 plus 36. And this equals 92 different ways to get from A to B. And whoa, we got the same answer. And that's because this is the correct example. That's because this is the correct answer. And yeah, that's 2 different ways. I highly recommend that you, if you have time, always try and solve each problem in 2 different ways on the target round.